FIFO page replacement. This is the simplest page replacement algorithm. FIFO stands for first in, first out. So the oldest page will be chosen to be replaced. This will be the victim page. For that we can assign a time, when the page is bought, and it is not strictly necessary to assign a time to know which one is oldest. We can use simply a queue. So the latest will be put in the tail, and in the head will be the oldest. So we will delete, or you can say we will use it as a victim frame, and we'll put or take this page out from this queue, and then we'll place it in the backing store. Quite easy to understand and implement. As you see here, we have a reference string. These are, say, the pages. We have 3 frames. So these 3 pages can be in memory at a time per process. So we have 3 frames here, 1, 2, 3. If this comes 1, 2, 3, so 1 will be placed here, 2 will be placed here, 3 will be placed here, because there is no page inside this frame. So there will be 3 page faults. Then 4 will come. Oldest one is 1. So we have to replace this 1 by 4. Okay, this will be replaced. Now 1 will come because we have just replaced this 4, and this is the newest one. We have to replace this 2 with this 1. Now in this 3, we have 4, 1, and now 3. Okay, now 2 will come. So we have to replace now this 3 with 2. Then 5 has come, and in this 4, 1, 2, the oldest is now 4. So we replace now this 4, right? 4 with 5. So 5 will come here. Now 1 will come again, and 1 will come again. We can see that what will happen. We have to replace which one? Since 5 has just come, and 3 and 4 is there, but this 4 is being here for quite a time, and this 1, as you see here, 1 has come now, but 4 has come before. So we have to replace this 1, right? So in this way we can replace all these strings. So in all there will be 9 page fault. But there is also a possibility we can increase the frame number. If we increase the frame number and we perform the same activity, that is first in, first out, then we see the page, because of increasing the frames, the page fault will increase. I'll show you with a proper example. If this is a string, see, 7 will come, 7 will go here. 0 will come, 0 will go here. 1 will come, 1 will go here. So 3 page faults. All these blue bars show the page fault. Now 2 has come, which has to be replaced. This 7 has to be replaced. This is the oldest one. 2 will come here. 0 already there, so there will be no page fault. 3. Now 3 has to replace which one? Because 0 is now the oldest, 3 will replace this 0. Now 0 has come. 1 is the oldest now, so 0 will replace this 1. Then 4 has come, which has to be replaced. 2 is the oldest, so 2 will be replaced by this 4. Again, now 2 has come. 2 will be replacing this 3, because this is now the oldest. 3 will come. 3 has come, but 0 is now the oldest, so 3 will go here. 0 has come. 0 will, this 4 is the oldest one, 0 will take this place. Since 3, 2 is already there, there will be no page fault here. 1 will come. 1 will replace this 2, right? Then 2 will come. 2 will replace this 3, so 2 will come here. Now 0 and 1 is there, there will be no page fault. 7 will come. 7 will come here, so 0 has to be replaced. Now 0 has come. 0 has to replace 1. 1 has come. 1 has to replace this 2, because all these which are oldest or out of 3 will be replaced. So there are 15 page faults. So there is a B-lady anomaly. Now B-lady anomaly is when you increase the frame size. If you increase the frame size, this is obvious that the page fault should decrease, but this is not the case. Just see this illustration. When we increase the number of frames, here the number of page fault has increased. This is the number of page frame, 3, and this is 4, so it has increased. This is called the B-lady anomaly.